All right, for this particular chapter, we're going to go ahead and skip number 4 where it says Don sculpts out a region. So I need you to skip that one, please, and also skip the you do that goes with that. So we're going to go ahead and move on to example 5. And it says find the volume of a room 16 feet by 14 feet by 8 feet. And the volume can be found by taking the length times the width times the height. So we know that the length here is 14, or actually that's the width. The length is 16, and it's 8 feet high. When we multiply all of those together, we get 1,792 cubic feet. So notice up to now we've just been dealing with feet squared. We're entering into the world of cubics because it's three-dimensional. We have a length, we have a height, and we have a width. Go ahead and press pause. Go ahead and solve this. When you're ready, come back. Okay, it says a square room with sides X. So my suggestion here is that you draw it out. It says it's a square room, so all the sides are X. And it says it has a volume of 1,900 cubics. So we're looking at 1,900 equals, we don't know the height, so we're looking at a cube here. We do not know the height, but we do know that each side is an X. So we've got X times X for the two sides of the square, plus whatever the height is. And it says express it in terms of height. So we're looking at 1,900 equals X squared times H. We've got to get H by itself, so we're dividing both sides by X squared. And the height of this particular squared room is 1,900 divided by X squared. All right, we have one more example, number 6. So let's go ahead and go through that. It says Mike's bedroom measures 16 feet by 14 feet and 9 feet tall. It's well insulated and it's on the west side of his house. How large of an air conditioner should we purchase? So here we're going to enter into our British thermal units, or BTUs. We have a formula that we use to find what size of air conditioning he needs. Why do we do this? If you get one that's too small, it overworks it. It's working all the time. It can't circulate the air, so it never gets cool. Use one that's too big, and you're overflowing the area, and you turn it on, and it's just always cold. So you need to make sure you're getting one exactly right for you. And to do that, you're going to use a formula that looks a little bit like this. It's the word while, or the acronym while, divided by 60. So let's break down what each one of these are. W is the width. H is the height. I is the insulation. And there's two things that go with this. This insulation will either be one of two numbers. If it is well insulated, you will put a 10, always. If it is poorly insulated, you will put an 18, and again, that is always. Those are the only two numbers that you will use for insulation. L is your length, and E stands for exposure, meaning what direction does your house face? So with that, you have 4 possible answers. It could either be north, it could be east, it could be south, or it could be west. And the numbers that go with this, they stay consistent every time as well. So if it's north, you will always use a 16. If it's east, you're going to use a 17. If it's south, you're going to use an 18. If it's west, we jump right over 19 and go to 20. So west would be 20. So let's determine here what each of our values are, and then we'll plug them in and see what we get. So it says that the width here, the width is 14 feet. The height is 9 feet. The insulation, it tells us it's well insulated. Well, we said here if it's well insulated, it's going to be a 10. The length is 16, and the exposure, it says the west side, so we've got right here, west is 20. Now, all we have to do is plug it into our formula. So we've got 14 times 9 times 10 times 16 times 20, all of that divided by 60. When I multiply all of my top numbers together, I get 403,200. Divide that by 60, and I end up with 6,720 BTUs. Now you'd think that we were done, but we've got one more thing that we need to do before we can finish here. The other thing you should know about air conditioning units is that they only come in BTU units per 1,000. So normally you would say, well, if it's a 5, 6, 7, 8, or 9, I'd round up. If it's a 4 through 0, I stay the same but round it down. So in this case, we would round it up to 7,000. And the answer is actually 7,000 BTUs. But I want to give you another little scenario here. If, let's just say, it had been 6,020 BTUs. I will tell you that the answer is still going to be 7,000 BTUs because with this, you always round up. And the reason is the number that it's giving you is the maximum size and in those calculations that it should be. So if it goes over even just a little bit, you need to get a bigger unit or you are going to overwork and cut the life of your air conditioning. So in this case, the final answer is a 7,000 BTU unit. So for the last check your understanding, go ahead and go through there. It says, and I'm sorry I don't have it up on the screen here, it says, what if Mike's room was poorly insulated instead of well insulated? So we're taking all the same figures except for making one change. So go ahead and press pause, take a second to solve this, come back when you're ready. Okay, let's see how you did. So, the width, it's still 14. The height is still 9. The insulation, that's what changed. It becomes an 18 now. The length is still 16, and it still faces west. So when I create this equation, I've got 14 times 9 times 18 times 16 times 20, all divided by 60. This time I end up with 725, 760. Divide that by 60, and I end up with 12,096 BTUs. Now, based on the last example that I gave you, hopefully you remembered that even though this is just over 12,000, you're going to round up, and the final answer is 13,000 BTUs. And that's it for this unit. Good job, everyone.